Okay, so today we're going to start off where we left yesterday. We had learned about how to do, whenever we're dealing with i's, to higher exponents. And I want you to just try this one today to get started, and then we'll proceed to the last type of question. Okay, so if we remember from yesterday, when it's above I to the fourth, we want to break it down to where we find a multiple that's smaller than 7 and is a multiple of 4. So we would have 1/2, and then it's I to the fourth times I to the third, because we would add our exponents to get 7. The I to the fourth automatically becomes 1, so this would be 1/2 I to the third. Then you just go back to your chart and check what I to the third is. I to the third is equal to negative I, so this would be 1/2, or negative 1/2 I. And that's our final answer. Okay. We called it expressions. You don't have to write any of this up at the top here. I would start with the because. So expressions in simplest form can't have square roots in the denominator. Because an imaginary unit represents a square root, you have to rationalize any denominator that contains an imaginary unit. To do this, multiply the numerator and denominator by the complex conjugate of the denominator. And I'll teach you what the complex conjugate is, even though we've already learned that in one of our previous sections. We'll go over what that is again. So we have 3 plus 10i over 5i. Just as an old school review, this is the numerator and this is the denominator. So I'm allowed to have an I in the numerator, but not in the denominator. So as soon as I see that this is 5i in the denominator, I know that's what I have to get rid of that. Okay. If you remember from the previous one of the previous sections, when we would have something like 1 plus 5i, and it asked us to find the complex conjugate, all we have to do is change the sign in front of the I. So the complex conjugate of this would be 1 minus 5i. So for this one, because it's just 5i, that's the same as 0 plus 5i. So you just change the sign in front of that 5i. So I'm going to multiply both the numerator and the denominator by a negative 5i. So if I multiply by this negative 5i, in the top, I'm going to have to distribute that to both of these terms. So it'd be negative 5i times 3. That'll give us negative 15i. Then negative 5i times 10i. That's going to give us a negative 50i squared. In the bottom, if I multiply 5i times negative 5i, that's going to give us negative 25i squared. But we know from our previous experiences that anytime we have an I squared, that's equal to negative 1. So now I can replace my I squareds with a negative 1. So this would still be negative 15i And then since this becomes a negative 1, it's negative 1 times negative 50. So that would be plus 50. Same thing in the denominator. If I multiply this by a negative 1, it's going to give me a positive 25. Now, because these are all a multiple of 5, I can reduce it. So I would divide each of these by 5. It would give me negative 3i plus 10, and then over 5. I can only do that because those are all divisible by 5. So this would be our final solution. Any questions? Okay, this one gets a little more complex just because we have a number in front of the negative 2i, but it really acts the same way. So our complex conjugate for this is 4 plus 2i. The only thing you have to do is change the sign in front of the 2i. So then I multiply both the top and bottom by 4 plus 2i. Now we learned yesterday that if we do something like this, we have to distribute it, the 4 to each term, and then the negative 2i to each term. And then we're going to have to do the same thing on top. So first here on the bottom, 4 times 4 gives me 16. 4 times 2i gives me plus 8i. Negative 2i times 4, that's minus 8i. Negative 2i times 2i would be minus 4i squared. Now before I try to simplify anything, I'm going to multiply my top out as well. So I have to do 2 times 4 and 2 times 2i, 8i times 4, and 2 times 2i, or 8i times 2i. 2 times 4 gives us 8. 2 times 2i gives us plus 4i. 8i times 4 is plus 32i. 8i times 2i gives us plus 16i squared. Now I can start to simplify this. So first on top I see a plus 16i squared. I see the I squared, that becomes a negative 1. So now it's negative 1 times 16. Additionally, I have like terms here. So 4i plus 32i gives me 36i. And then, like I said, I squared is negative 1. So 16 times negative 1 is minus 16. In the denominator, I have my 16. And it's plus 8i minus 8i. So those cancel each other out. And I have negative 4i squared, which means I squared is negative 1. Negative 1 times negative 4 gives me plus 4. The last step is to simplify. I can do 8 minus 16, which is negative 8, plus 36i over 16 plus 4, which is 20. All of these numbers are divisible by 2. So negative 8 divided by 2. Well, actually, they're all divisible by 4 as well. So I can go with 4. So negative 8 divided by 4 is negative 2. 36 divided by 4 is 9. And then 20 divided by 4 is 5. So that's my final answer. All right, last one here. Here we just have negative I in the denominator. So I want you to try this one and then do it together. All right, we'll try this one. So because this is just negative I, I'm changing the sign in front of the I and multiplying. So I multiply both the top and bottom by I. On top, this is going to become 3i plus 8i squared. And on the bottom, this just becomes negative I squared. Now I replace my I squareds with a negative 1. It's 3i minus 8. Then this is a negative of a negative 1. So that would be positive 1. Anytime we have 1 in the denominator, it just becomes like a whole number. So we don't have to worry about the 1 anymore. And we write it in our form, a plus bi, so it'd be negative 8 plus 3i.